today. I'd like to thank everybody, first of all, for joining us. I think we have some people right across the country, actually, at this. So thank you very much. Some of you out west are getting up pretty early. Just a little brief intro on Everest. Everest Automation, for anyone who doesn't know, we strive and I think are very successful at being a partner for our clients' process automation and analytical requirements and needs. We have 8 offices that serve their regions, as well as we're responsible for some products right across the country. Promecon, who is presenting today, Alex from Promecon is presenting the webinar on airflow measurement for the cement industry. This is one of the products that we are responsible for across the country. And Alex has got a lot of experience. He's got over 20 years experience in this field, and he is very well versed with installing equipment, analyzing what's required for some of these difficult airflow measurements that you find in your industry. And so we really encourage you to ask the questions, anything you want more clarity on, stuff like that, just zap us in there on a chat and we'll make sure that we address it. And so without further ado, I would like to first of all thank Alex and turn the presentation over to him. Thank you, Alex.
Yeah, hello, good morning or good afternoon here from Germany. I will just have a quick step through the contents, what the presentation will be about today. Something about Promecon, the company, where it comes from. Then the Mechon Air, that's the product we are talking about today. Regarding measurement principle, the installation, technical data, and the advantages of the technology. And then we'll have a look at different applications in the cement plant, where you have a lot of dusty flows, where the measurement can be applied to. Of course, air flows, dirty air, so contaminated with dust, or clean air, flue gas, and then emission might also be a topic for the measurement. And at the end, we will have a quick look on the advantages over the conventional differential pressure measurements, which are most places a good solution, but once you're dealing with dust, it will give us or it will give some problems in the operation. So who is Promecon? So Promecon is coming from Germany. So it was founded 1995. 25 years ago, and our company headquarter is located in Barleben, close to Magdeburg, which is about 1 hour away from Berlin, from the capital. And we produce process and measurement technology for the power industry, cement industry. Waste to energy is a big topic right now here in Europe. And then we have some special products also for the smelter industry. The measurement systems, they are taken for the analysis and for the control and optimization of thermal processes. So we have a wide range of the measurements for the applications. Some of them are applied in critical processes like the firing of power plants, where we have to meet certain safety rules, SIL2 compliance, and some are also for emission monitoring, which is a certified process. Yeah, the products help to increase the availability, to save the energy and money, and also to protect the environment. And one of the big advantages of these the airflow measurement is that it's mostly maintenance free. So you usually don't have to touch the measurement once it's installed and running. So here we have a picture of the Mechon Air system. Basically, we have a evaluation box which is doing the calculation, and then we have 2 probes which are installed in the duct, and they are getting the information of the airflow and transferring it to the processing box. So on the left side we have our new box, which is a compact system with an automatic adjustment of the sensitivity of the sensors, and on the right side we have the, let's say, the classic measurement system, which is basically the same principles, the same processes and calculations we do with those, but it's a little bit simpler in the design. So the measurement principle of the Mechon Air System is quite nice to see and understand. So we have 2 sensors placed in the flow, in the duct, one after the other. We have an upstream and a downstream sensor, and they are mounted at a certain distance. And what they do is they are scanning the electrostatic charging, or the electrostatic pattern of the charged dust particles passing the sensors. And the charging comes from, you probably know that all ducts need to be grounded properly if you're transporting dust or any kind of isolating material. And this electrostatic charging comes from particle-to-particle collisions and from collisions to the duct walls. And these 2 sensors, they are giving a signal. So we have the sensor 1, which is the upstream sensor, and the sensor 2 signal, the downstream sensor. And this pattern is scanned continuously. And then we take these 2 patterns and evaluate both regarding the time shift between those. In this nice example, you can see directly the time shift between the 2 sensor patterns, and from that we are doing correlation analysis to calculate the exact distance between the 2 signals. This is given by the correlation function and the peak we find there. So if you have identical signals, it will be just a fine line at the time shift. But if you have a spread or little change between the 2 sensors and the 2 positions, then you get a bit wider peak, and this is evaluated regarding the time shift. And then you have basically what you need to calculate the velocity. And from the gas velocity, you can calculate the gas flow. And then with temperature and pressure, you can correct it to standard conditions, to standard temperature and pressure. The Mechon Air installation is giving here in the quick picture. You see the 2 sensors, sensor 1 and sensor 2, installed in the gas flow. So let's say the minimum straight section we need upstream for the sensors is 3 inner diameter. Of course, longer distances with less stratification from bends and or any kind of other disturbances are beneficial then for the flow conditions in the measurement section. But you have these 2 sensors installed in the duct. So you have a sensor 1, sensor 2. They are mounted in these brackets, in these mounting adapters, which are connected with a beam. This beam is basically to ensure that the sensors aligned parallel, or the antennas which are inside of the process, because you can probably imagine if the antennas are not parallel and the distance is not controlled or certified, then of course you have a uncertain distance to calculate your flow velocity. The brackets are basically connectors. They are screwed on. They have a gasket, and you just insert the sensor and screw this nut. Of course, here on the left side, you see the alignment of the sensors should be in flow direction, one after the other, and they shouldn't be like cross indicated there in the picture. Another advantage of this of the measurement is that it's just evaluating the vector between the two sensors. So once you get a swirled flow, which you can find in many ducts with several bands after each other, you won't get the, let's say, the rotating component of the flow. You will just get the vector between the sensor 1 and sensor 2, and any kind of rotation or turbulence will not affect the flow velocity in the reading. So this makes it also quite robust in the evaluation. When we look at the installation, we have this scheme here with a Mechon Air box, which has on one side needs a power supply. This could be 230 AC or 24 volts DC. We need a functional ground, guaranteeing that the sensors and the Mechon Air box are on the same ground for the correct evaluation of the electrostatic pattern we receive from the sensors. Then we have the two sensors connected to the Mechon Air box with a 5-pole shielded cable. The maximum distance we have here 20 meters, could be extended up to 50 meters, but usually with a single channel Mechon Air box, you can always find a good place in the area of the measurement. Within 20 meters should be possible. And then of course for the DCS and for the control purpose, there will be a 4 to 20 milliamp output for the measurement signal. And of course a sensor fault and system fault can also be connected to the Mechon Air box. If no sensor fault is connected, the 4 to 20 milliamp output can be extended to 0 to 20 milliamp output, and then all fault conditions are displayed in milliamps below 3.5 milliamp. So then you get a fault from your converter, and you can also use it to analyze the fault condition in the box. For clean air applications, which might be, when we think about the cement industry, might be in the clinker cooler or any kind of fresh air, or even after a very effective filter. We have an additional probe which is inserted into the flow, in the airflow, which is, we call it range extender. It is basically a high voltage source which is ionizing the air, and once you have the ions in the air flying with the same velocity like your air, we get again electrostatic flow pattern on the sensors, and we can use the same algorithm to evaluate the airflow. It also gives quite a benefit if we are looking for low air velocities or low flow velocities, which is basically starting at 3 meters per second. then this range extender is also beneficial because you get at low flow velocities already quite high and good repeatable signals for the evaluation. If you're running the Mechon Air System just on the dust, you will need something like 5 meters per second to 6 meters per second to get reliable readings just from the airflow. It's also related to the charging of the dust when it's transported with low velocities. Then of course the electrostatic charging of the dust is not so high. It's not so distinctive. The technical data for the measurement system, we have a temperature range for the probes up to 1000 degrees C. So especially for the tertiary air application, we have probes which can be applied to the hot tertiary air up to 1000 degrees C. The velocity range is in the area between 3 and 100 meters per second, where the 100 meters per second are a bit academic because the correlation evaluation gives you, of course, the possibility to evaluate much higher flows, but it is about the flow velocities we can find in industrial applications. Other applications like aviation and these things, they are might be possible, but they're still in, let's say, in somewhere in the future. The dust concentration is between 0 and 3000 grams per cubic meter, where, let's say, the lower end is then clean air, and we like to use the range extender up to dust concentrations, or for dust concentrations below 100 milligrams per cubic meter. And then on the upper end, you can measure very high loaded gas flows with dust. For example, after the roller mills. So we're using the same technology to measure the coal dust in coal power plants, where they transport the coal to the burners, which with a pneumatic system with a primary air, and there we usually find concentrations up to 500 grams per cubic meter. But we also tested it in let's say, in high dense flows up to 3000 grams per cubic meter. So it's all possible if you have some kind of applications like that. For this abrasive, if you have a lot of dust there, then we also have some special sensors which are abrasive resistant, and they last for a very long time in these high dense flows. Typical accuracy is plus minus 2% on the full span. The repeatability, that's one of the advantage of the measurement system, is that it is working like it's a time measurement. So and the time can be measured with let's say the new, modern processors quite accurate, and so we have a very high repeatability on the signal. The reaction time is around 1 second. IOs, we have a 4 to 20 milliamp output, and the fault signals, and we have an IP66 protection of the board and the sensors. Of course, if there are, let's say, higher dust or water loads, then of course an additional protection should be feasible. We have also, as I mentioned before, an SIL2, also safety integrity level 2 certified version of this measurement, which is used to measure the combustion air in power plants, where we have in different countries different regulations, but a lot of modern new build power plants in Europe, they require this SIL2 certificate, and we have the certification done for this measurement. Yeah, the advantages is that we have a direct measurement of the flow, so no K factors are necessary. We also usually don't need a calibration. And one of the big advantages is there's no drift of this measurement, which is can be found for differential pressure measurements. We have a little word on that a bit later. It can usually apply to the normal duct configuration, so you don't have to put in some kind of orifices or venturi tubes or anything like that. No additional tubing there. It is maintenance free, so you don't have to do a regular cleaning or maintenance on the sensors. So it's digital, simple, and a safe measurement of airflow, and of course from combustion gas, drift and calibration free and maintenance free. So here's an overview about the possible applications for the Mechon Air System in the cement plant. We have several applications, or we have all these applications already installed all over the world. One of the main, let's say the main applications we find is usually the downcomer after the preheating tower, and then of course the mill or the airflow for the cement mill and also for the raw mill. These are let's say the most common applications we find, but there are a lot of other applications possible, and we find we all installed them by now, which are or could be of interest for you as a cement plant. So one of the examples here is vertical roller mill, the raw mill. You can install it before and after the raw mill. Could be usually we find up to 200 grams per cubic meter dust content in the after the mill, but as I explained before, it could be higher. So if you're using different air to dust ratio, then of course it can be applied. The typical temperatures we see there are 70 to 200 degrees C. If for any reason you have higher temperatures, then of course you can use different sensors. The problem is usually that the ID fan has to be operated in a way that the specific airflow for the product is achieved. Deviations might result in blockages or have an influence on the fineness of the material. Sorry. And the general day-to-day operation is adjusted with a security factor usually of 15%. If you're just running your airflow on RPMs, then you're usually putting a higher airflow through the mill. This higher airflow, of course, gives some problems in the operation or might cause additional costs. The solution, if you apply the Mechon Air System to your inlet or outlet of the mill, then of course you have a direct measurement of the flow, and you can integrate it into your control loop. You can optimize the airflow and can use the potential to reduce this excess air you're using. And then of course, when you look on excess air, on a fan, then of course you can achieve electrical power saving. And one big advantage is you apply the measurement and it's maintenance and calibration free. The result could be, of course, depending on your process, could be within 1 kilowatt hour per ton of grinding material. So you have around 150 kilowatt hours saved on for 150-ton mill. So if you're considering, so sorry, this is in euros, this calculation, on 7 cent per kilowatt hour, it's about 10 euros per hour. So the ROE can be achieved within, let's say, several thousand of hours easily, if you're putting it correctly to your grinding control of your mill. The next application, which is from my side, I think the most common application for this measurement, and gives mainly very high potential for optimization, is the downcomer. So you see here the downcomer duct of after the preheating tower, and the measurement is just installed directly to the duct. You don't have to put any other installation there. And the problem is that the usual control of the furnace is measured or is controlled with on the oxygen level, measured at the gooseneck of the preheater tower. So at the axis of the preheater tower, you have your O2 measurement, and with the fluctuating heating values of your fuels, so you're not only firing on coal, you're using alternative fuels. Here in Europe, it's a very common thing to optimize the amount of alternative fuels, or even waste and tires, to earn money, because you're burning this waste. And so with the fluctuating heating values, then of course the O2 value can be fluctuate on the same level, and it's very hard to put on continuous control on this O2 level. And the solution is to control the ID fan on the fast and the repeatable Mechon Air measurement values. The integration into the Kiln master control. So one of our biggest clients is Lafarge-Holcim, which have their own master control for their plants, and every time they install to their plants, they use our measurement to get a highly repeatable and reliable measurement of the flow through the downcomer. And this, of course, if you have a more repeatable measurement on the flow, then you can save your fuel costs. So the reduction of the energy consumption might be up to 5% in steady kiln operation. So 3,000 tons per day kiln needs about 360 tons coal per day. So the savings could be 18 tons per day, considering a coal price of 120 euro per ton. It's around 2,000 euros per day. If you're using 70% alternative fuels, it's still around 20,000 euros per month. So applied with the right kiln master control, you have RE tons, which are can be named in months. Another application is the bypass. So the bypass is used to extract the right gas amount in areas where sulfur and alkali concentrations are accumulating within the material, because it is evaporated in the furnace, but in the preheater tower it's condensing back to the material, and you have to extract this dust from the process. You can use the measurement then to maximize the waste heat to the clinker of the clinker cooler. if you have a VHR boiler there installed. Of course, you can optimize the performance of the kiln. It gives you also the potential for energy savings, and the airflow in the process can be controlled more accurately. Here we have an example where we had a comparing measurement with the VDZ, which is, let's say, one of the major measurement groups in the German cement industry, which are doing certified measurements of flows by hands with pitot and also other extractive probes. And here we have the Mechon Air Portable, which is a variety of the measurement, where you also have a display, foldable sensors, both in convenient cases to carry from point to point in your plant. The next application we already installed, or we have experience with, is a tertiary air in the cement plant. Here we have slightly different conditions. We have a lot higher temperature, and we have to deal with a clinker dust, which also might get conducting with a higher temperature. This is a bit more difficult application, but we have quite good solutions with sensors and mounting adapters and a purging system to measure this flow. So with this, you control the hot primary air, so combustion air, to your pre-calciner. You have to control it. You don't have an optimal energy distribution. You have to assure the steady process, and one of the problems is the downtime of the calciner, because you cannot be operated continuously. With the flow measurement in the tertiary air, you can regulate the load on your pre-calciner from the air side. You get a better energy distribution and a better calcination in this area. You can stabilize your process. You can detect blockages due to deposits in your tertiary air duct, because we found with a lot of clients that say we at a certain point we get so much material accumulated in the tertiary air dust that we have to stop it, isolate it, and to clean it. By this, you can reduce the downtime of your calciner up to 60%, and you have a better control and usage of alternative fuels in your calciner. The clinker cooler is one other application we equipped with our measurements. The ID fan, the problem is there is that they have to be operated in such a way that specific airflow is achieved. Deviation of the specific airflow causes that more particles are carried out by the airflow, and you have problems with the balance of the kiln and combustion air. Regulation of the gas flow, the solution with the Mechon Air measurement gives you a direct measurement of the flow and the direct measurement of the airflows. You get a detailed control of your cooling process, and you can establish a balance of kiln and combustion air. And another application is the flow to the waste heat recovery boiler, where of course you have a a gas flow with a high enthalpy, and you want to you have the possibility to measure it. So you get a precise measurement of the heat gas going in and out of the boiler. You have the opportunity for an online balance and efficiency calculation. Yeah, how do you call it? Yeah, you can calculate the enthalpy. One big advantage is drift and calibration free, and you get a precise and repeatable measurement among different dust loadings. Of course, the dust load can vary in this area. Yeah, here we have an example to an HQC boiler. I think it was an Indian plant. Here we see also with bigger ducts around or above 2.5 meters, around 3 meters, additional sets of sensors should be applied to the flow to get a bigger coverage of the duct. The sensors, they have a coverage of about 40 centimeters around the sensor, detecting the electric field. But with higher or with bigger ducts, more sensors should be applied to the flow. If you have good and long inlet conditions, for example, like a downcomer duct where you have more than 10D straight section before the sensors, then of course you can still operate it with one set of sensors. Yeah, at the end, I'm nearly done with the presentation. We have some motivations to change from DP measurements. One of the major problems, or one of the points which brought us to the, let's say, invention of those measurements was the demand in power plants that they say we always have drifting measurements, not because of the transmitters are bad. They had issues because of the plugging and the blocking of the differential pressure tubes by the dust. And if you just plug one side, or if it's partially plugged, then of course here you have the barometric pressure, which is also pushing the differential pressure into certain regions, and this gives a systematic drift of the measurement, and this causes an unnecessary rise of airflow and leads to misbalance of fuel and air relation, as well as increased power consumption of the fans, because one of the big consumers in the plant, or electrical consumers in the plant, are usually the fans. Then of course the permanent cleaning of differential pressure measurements causes considerable maintenance costs, because you have to pay the person who's cleaning your DP measurements. Then for the cleaning, it requires additional installation of platforms for maintaining of all DP measurements, which is, when you plan a new plant, of course, an additional cost factor. The alternative solution with Mechon Air measurement from Promecon solves these problems. It saves costs for maintenance, power consumptions, and constructive devices, and it increases safety. The Mechon Air System is a direct measurement of the flow, and it's calibration free. And the measurement principle is digital, reliable, and absolutely drift free. So there are many good arguments to use this technology in dust loading applications. So here are some of the partners, and now I saw I had to correct the this last slide. So of course I'm not the CEO of Promecon. I'm the application engineer But here you see some of our clients all over the world. It's Lafarge-Holcim, Heidelberg Cement, FR Smith, Lösche, Lehigh Cement Group, and Italcementi. So thank you for your interest in this presentation, and I will be happy to discuss with you some questions or answer your questions.